Hello and welcome. This is class 7. I again am Dennis Stoverspike, in case you've forgotten or don't know. And in class 7, we're going to in a sense take a step back, one or two steps back. We're going to discuss really mediation, and we'll discuss mediation within the process model. So we're going to discuss how to do mediation or mediation analysis. And specifically, in discussing mediation, we're going to look at the Hayes process model. Now, when I designed this class at the time, Hayes had still not created an official process piece of software or program for use on R. So at the time I created this class, process was not available yet on R. My understanding is process is now available on R in a beta version. It won't be available in a full version or a non-beta version until later in the spring, but you can now get it in a beta version for R. We're using process through SPSS, and so does field. So you can add on process to SPSS. Once you add it on, it appears right in the menu, so it's really easy to use. It does help if you're going to use process to read Hayes's books. So it does help to go out and get to Hayes's book and read his books. If for no other reason, he lists all these different models he has, which get quite complex. Okay, but anyway, we'll be talking about the analyzing for mediation and the process model or the process program or the process software. Okay, what is mediation? Well, mediation is really a great thing, really, if you're a student or a graduate student, because it's going to help you do, I think, your thesis or dissertation. I tell students who are interested in doing research or an original thesis or dissertation, the best way is to think of two important or practical variables you might be interested in. We'll label them X and Y. Now, just because you're interested in X and Y and everybody else is interested in X and Y doesn't mean a dissertation committee is going to approve your dissertation. And it doesn't mean that it'll get published. Because unfortunately, in the minds of many, theses and dissertations and even getting articles published in journals doesn't require solving practical problems. It involves having a theory and testing that theory. But there's an easy way to build theories. And the way to build theories is to have variables that you add as mediators or moderators. Now, again, we've already discussed moderators, and we'll be discussing moderators next week in class 8. But in this class, we'll be discussing mediators. So mediation is really trying to make a causal statement, often out of non-causal data or out of non-experiments. So one of the uses of mediation is to try to make causal statements in those situations in which you either have archival data or you have survey data, but you haven't done either a true or a quasi-experiment. Now, of course, we can argue as to whether you can really then imply cause or not, but that's a different issue and one we can discuss, but it's a different issue. Now, of course, you can also use mediators. As a matter of fact, you might argue it's where they'd be particularly valuable when you have manipulated the independent variable. So we can always look at mediators with an actual true experiment with a manipulated independent variable as well. So anyway, mediation tries to make causal statements. It's a way of building theories. It seeks to identify and explains the mechanism or process that underlies an observed relationship between an independent variable and a dependent variable via the inclusion of a third hypothetical variable known as a mediator variable. Also a mediating variable, an intermediary variable, or intervening variable. Geez, looks like I'm having trouble talking today. Rather than a direct causal relationship between the independent variable and the dependent variable, a mediation model proposes that the independent variable influences the non-observable mediator variable, which in turn influences the dependent variable. Of course, to study it, we have to make that mediator variable then observable. So even though we say non-observable here, to study the process, the mediator variable has to become observable or measured. So here's one sort of typical mediation model. It's one of the areas of psychology where there's really a lack of theory. There's a theory called stereotype threat. If you're familiar with the theory, it argues that minorities often underperform on tests because they feel that taking the test is a challenge to their group. That's probably the prime theory, that in taking the test, they're representing their group. And if they do poorly, it's going to reflect poorly on their whole group. And so minorities feel this stereotype threat, and it reduces their test performance. And in particular, they're going to experience when either the test medium or the test format or the test content is one traditionally associated with lower performance by their group. And so frequently we're actually manipulating the independent variable. And there is quite a bit of research that even if the effect is small, we can constantly replicate a relationship between certain test media or content and diminished test performance for minorities. Now, of course, the question is why or how does that occur? Now, one explanation might be test anxiety. So if I wanted to develop a thesis or dissertation and test this idea, I start out, I have my independent variable test medium. For example, we have a test, and in one case we describe it as an intelligence test, and in another case we just describe it as a problem-solving test. And then we have test performance, which of course is how we score on the test. And we know, or at least hope, that in our study test medium will affect test performance. And now what we do is insert this mediating variable that we also measure. And so, for example, maybe we give a test of test anxiety because we're arguing that the mediator between test medium and test performance is test anxiety. Here would be another example. I've given this before. This is a police incident with a veteran. We argue that when a police officer sees a veteran involved in an incident, they're going to have to make a decision as to whether to use force, whether to arrest the person. So they're going to have to make various decisions. Well, what's the mediator? Well, we might argue that the mediator is perceived danger. So now we can have a model. We can manipulate what kind of an incident the veteran is involved in. We can then measure the mediator, perceived danger. And then we measure, of course, the dependent variable. What kind of decision does the police officer make about an arrest or the use of force? And again, we mentioned the Fishbein and Eisen model before. This is really a classic mediator model because we have these sort of independent variables, and they all influence intent, which then influences behavior. So in this classic Fishbein and Eisen model, the mediator is our intent. Okay, there's other ways to do mediation analysis. We don't really need to use process. We could just use hierarchical regression. But we're going to use process because one, field uses it, and two, that's what we're teaching right now, the use of process. And again, process is a technique, a routine, a program developed by Hayes for the analysis of mediation and moderation. So again, mediation, now this is slides from Andy Field. Mediation refers to a situation when the relationship between a predicted variable and an outcome variable can be explained by the relationship to a third variable, which we call the mediator. So our simple relationship again would be predictor to outcome, and our effect we label C. Our mediated relationship is predictor to outcome. And now we have two effects, though. We have an indirect effect and a direct effect. The direct effect we're going to indicate by C prime. The indirect effect is the effect of the predictor to the mediator and the mediator to the outcome. So the indirect effect is predictor to mediator, mediator to outcome. That's the indirect effect. The direct effect is predictor directly to the outcome. And so we're going to see to what extent the mediator explains the relationship between the predictor and the outcome. Of course, the most interesting thing would be, right, if we had full mediation. That would be really interesting. If there's no direct effect, if the whole effect is indirect, that is, the only effect of the predictor on the outcome is through this mediator, through the A path and the B path, that would really be interesting. That doesn't always happen, or maybe even usually happen. Usually, we end up with an indirect effect and a direct effect. Now, another sort of interesting aspect of this would be, what if there is no predictor-outcome relationship? Can we still have a mediated relationship? This is the topic of a lot of debate. I hope some of the articles I assigned discuss this. If not, we'll discuss it. But there's debate in the field. There's a debate in the field. Some experts would argue if there's no relationship between the predictor and the outcome, you can't have a mediated relationship. Other people would argue even if there's not a simple relationship, you can still have a mediated relationship. So there's a little bit of dispute there. I would argue it probably partially depends on what kind of data you have. I mean, if you're manipulating your predictor and it has no effect on the outcome, only an effect on the mediator, then I have to question what that's really telling you. That is, if you've manipulated the predictor. On the other hand, if the predictor is not one that's manipulated, if you're just using, for example, survey data here, then maybe the fact that there's no direct relationship, but there is a mediator, or no simple relationship, but there is a mediator or indirect effect relationship, does in fact tell you something. So we'll probably again be discussing that more when we look at the articles, hopefully. But it's just a topic to be aware of. Okay, probably the study of mediation started with Barron and Kenny, 1986. And I believe I've given you some readings from Barron and Kenny. And Barron and Kenny argue that mediation can be tested through 3 regression models: predicting the outcome from the predictor variable, predicting the mediator from the predictor variable, and predicting the outcome from both the predictor variable and the mediator. And then you can use that information to get your paths. Barron and Kenny also argue there's 4 conditions of mediation. The predictor, and so you'll note, this is what we were just talking about. Barron and Kenny say the predictor must significantly predict the outcome variable. So that's number 1 there. Now, as I said, since Barron and Kenny, not everyone agrees with that. The predictor must significantly predict the mediator. Number 3, the mediator must significantly predict the outcome variable. And then 4, the predictor variable must predict the outcome variable less strongly in model 3 than in model 1. So the predictor variable must predict the outcome variable less strongly in model 3 than in model 1. So when we get to model 3, when we're partialing out the mediator, the effect of the predictor must be lower in model 3 than in model 1, or condition 3 than condition 1, if you understand that, I hope. Okay, there's a number of limitations, though, to Barron and Kenny's approach. One of the major limitations is how much of a reduction in the relationship between the predictor and outcome is necessary to infer mediation. So this is sort of what I talked about before. You don't always get full mediation. So if you're not getting full mediation, how much of a reduction in the relationship between the predictor and outcome is necessary to say there's mediation going on? People tend to look for a change in significance, which can lead to the all or nothing thinking that p-values encourage. That's saying that's a problem. There is also something called a Sobel test. The Sobel test is from 1982. It's an alternative used to estimate the indirect effect and its significance. Basically, if the Sobel test is significant, there is significant mediation. One of the problems, of course, is significance test depends upon sample size, but, that's always true. To me, that's not a huge problem because we know that's always true, that significance tests are going to depend upon sample size. It's probably best to read Field to understand these next couple slides. I'll try to explain them, but, Field has a lot more room to write text explaining these various effects. And also, Field sort of starts off by saying you probably don't need any of these effect sizes because probably the best indicator of the effects are the b-values, the regression weights. So Field does start out by saying that probably the best thing to do is just look at the b-values. But then he goes on to still give these other effects. And some of them have names and others do not. But he starts with the indirect effect, where the indirect effect as an effect size is simply A times B. And if you go back, again, while I'm recording these, I can't go back and show you a past slide. But if we went back, or if you go back to the slide or in the book where it shows you the model, A is the path from the predictor to the mediator. B is the path from the mediator to the outcome. So he's saying the indirect effect is equal to A times B. There's also an indirect effect partially standardized, which equals A times B divided by the standard deviation of the outcome. Then there's an indirect effect standardized, which is A times B divided by the standard deviation of the outcome times the standard deviation of the predictor. And I think he gives that one a name. Let me look here. And it's, yes, he calls it the index of mediation. So he calls that the index of mediation. So these exist. He discusses them in the book. You're not going to be calculating them anyway. You're going to be using process. But I guess it's useful to know what they are and what they mean. We can then also calculate additional effect sizes. So I don't know that these have names, and I don't think I'm looking at Field. I'm sort of treating it like a Bible right now and looking at it as our Bible statistics, and I'm looking at it to see if Field gives them any names, and I don't see that he does, and I don't know of names for them, but we have what he calls P sub m, and P sub m is just AB divided by C. Now, we just discussed what A and B are, and of course, C, again, is that original simple relationship between the predictor and outcome. We then have R sub m, which is AB divided by C prime, where C prime is the estimate of the remaining direct effect between the predictor and the outcome. And then we have this down here, if I still have my pointer, we have our regression estimate of the influence due to mediation. So we have this regression estimate. And again, if you'd like further explanation as to what this is and what it means, go to page 372 in the Field textbook. If you have the North American version, and you'll see an extended discussion of what exactly this means. Okay, then. Next, Field gives us an example of another mediation model. And in this mediation model, he's looking at the impact of pornography viewing consumption on infidelity in a partnership. And the mediating variable is relationship commitment. So in this model, there is, of course, a simple relationship between pornography consumption and infidelity. That would be C, which we don't see here. But there's also then an indirect effect. That's pornography consumption impacts relationship commitment, and that's our A. And relationship commitment then impacts infidelity, which is our B. And that's our indirect effect. And of course, if we take that out, then what we have left is this C prime, which is this direct effect of pornography consumption on infidelity. And then he's going to do a study. So as we will, he's going to use the process model in SPSS. Now, his process model is a little different than mine. I don't know if that's because I have a different process model, because I have a different version of SPSS, or because he's in England. I'm not sure why his process model is different from mine, but his process model is a little different. I mean, it's not going to have an impact on anything, but for example, these options are different in my version. So if you've downloaded a version of process into SPSS, I'm not sure which will match yours, but I get different options than he does when I go to run SPSS, but that's not going to really matter for us here. So what he's going to look at here again is, in terms of his variables, his outcome variable, as you can see that he's entered here, is physical infidelity. His independent variable is a log transformed pornography variable. And then his mediator variable is commitment. And you can see he's going to be bootstrapping. He's going to get confidence intervals. Oh, this is really important, because it took me a long time to figure this out because it's hard to see. You have to put the correct model in here or nothing's going to work. And you're going to get lots of errors. So you have to find the correct model number here. Now, for a simple mediation like this, 4 is the correct model. So if you have this kind of simple mediation, 4 is always going to be your correct model. If you have anything more complex, you really need to get Hayes's book and find the correct model number. I don't know how else you're supposed to do this. I don't know if there's also people who have put up sort of pirated versions of Hayes's book where they show all the models, or the appendix that has all these models in it. But you need to go to the appendix in Hayes's book and look up the correct model, or nothing is going to work. So for this simple mediated model, the model number is 4. All right, so you have to make sure 4 is entered here where it says model number. It took me a long, I don't know why, it took me a long time to find out where that model number was entered, actually. And then, of course, I had to go to the book and look up the right models for the situation. But for, again, this simple mediation that we'll be doing, the model number is 4. Okay, and then if you click on options, you get a number of options. And what you can see here is that some options are only available in certain models. So again, if you pick an option that's not available in a model, it either won't run it or it'll give you an error. It might not even run the whole thing. So you need to make sure that you're picking options that are permissible under the model that you're running. And again, this looks different in my version of process for SPSS. The choices are different. For example, I don't think I have the Sobel test. So maybe Hayes has eliminated that, or maybe some versions of SPSS still have that. I can't tell you. All I can tell you is what my version shows. And my version is a little different. It doesn't show this Sobel test. So anyway, we pick our options. We pick, again, our outcome or dependent variable, or our Y, is going to be physical infidelity. Our independent variable is pornography consumption, but it's log transformed pornography consumption. And our mediator variable is commitment. Now you notice there's other options we don't have to worry about here. There's a multi-categorical option if you're using categorical variables that are more than dichotomous, that have multiple categories. There's a long name option because, as they discuss in the book, there's a problem with really long names in process. And you'll see also there's some options, like, for example, you can mean center. I think this is one of the things, and again, in the SPSS version I have, this actually is a different window that opens up and gives you a number of choices. But anyway, we'll stick to Field's slides for right now, and we'll get to my slides later. And so we say continue. Okay, so now you can see that what the output starts with is that A path. So if you go back and look at the model starts, or the output starts, by showing you the relationship between X, pornography consumption, and the mediator. So at this point, we're not even looking at the outcome, or Y, physical infidelity. We're just looking at the relationship between pornography consumption and commitment. So the outcome variable is going to be commitment. So this is the top part of that model, the mediation, and we're looking to see, hey, is there really a relationship between pornography consumption and commitment? And so here's our model summary. Our R is 0.1418. Our R squared is rather low, 0.0201. Although not atypical for psychology. So what's that saying? Think to yourself, what does that say or tell me? Well, what it tells me is about 2% of the variance in commitment is being explained by pornography consumption. So about 2% of the variance in commitment is being explained by pornography consumption. Here's our mean squared error. Here's our F value with degrees of freedom. And here's our P. And it is significant at the 0.05 level. Our P is 0.0284, which would be significant at the 0.05 level. And then it gives us our B coefficients here. It gives us the constant, and then it gives us the coefficient for pornography. You can see it's negative. So as pornography consumption goes up, commitment goes down, which makes sense. So as pornography consumption goes up, commitment goes down. Although again, it's actually a transformation of the pornography variable. Of course, we get our T's associated with each variable. They're both significant. Again, the constant probably doesn't really matter much, but the P associated with pornography is, again, 0.0284, and it is significant. And then we get the lower and upper confidence intervals on this estimate of B. One of the things you're going to notice, Hayes is not a fan of standardized coefficients of beta, a big B beta of standardized coefficients. And this is a debate you'll find in the literature as to people who argue, hey, betas are really valuable. Why aren't I getting them? But Hayes doesn't really believe in them all that much, from what I understand. If you ever meet Hayes, you can ask him and say, Dennis said this, and maybe you can say Dennis is wrong. But Hayes doesn't seem to be a big believer in standardized betas. So just so you're aware of that, Hayes believes you should look at those at the unstandardized B coefficients, the model including the constant. I think that's because Hayes is saying you should be taking your units of measurement seriously when you're looking at mediation and moderation. That's one idea. Okay, so that's the first thing we get. So the first output actually has nothing to do with the outcome variable or the dependent variable or the Y of physical infidelity. It's only looking at, does pornography predict commitment? Okay, so here's our second piece of output. In your book, this is labeled output 11.5. And now we're predicting physical infidelity from both commitment and pornography consumption. So this is really going to give us those other two paths. This, in a sense, is giving us a type of B path and a type of C prime path. Okay, so this is giving us, in a sense, a type of B and a type of C prime path, because we're getting, of course, the influence of this variable on the dependent variable after you've controlled or held constant the other variable, right? I mean, that's, again, just simple regression. So, but let's go back a second. We have the R. We now have an overall R of 0.3383, which gives us an R square of 0.1144, which means we're explaining 11% of the variance in the outcome variable. The P here is really low, 0.0000, so it's significant. We can see now the B parameters for the constant for commitment. In this case, commitment now has a negative relationship with physical infidelity, which makes sense, again, because we're looking at sort of a negative variable physical infidelity. The more commitment you have, the less likely you are to engage in physical infidelity. And it is significant, 0.0000. Again, you get your T here, your standard error here, your coefficient here, and your lower and upper confidence intervals here. Also, of course, pornography does have then a direct effect after you remove the indirect effect. And that direct effect is a coefficient of 0.4573. Here's our standard error, our T. Our P is 0.0196. So pornography still has a significant effect on physical infidelity after you control for commitment. But I mean, that doesn't tell the whole story. We wouldn't need process if that tells the whole story. Next we get as the next piece of output, and in the book, this is 11.6 on page 374. So we get the total effect model. So we get the total effect model. Now, all this is, if you look at it, you can see that all this is a simple regression analysis, or the equivalent of a correlation. So this is telling us that if we take the mediator out, if we just look at the impact of pornography consumption on physical infidelity, the R is 0.1859, the R squared is 0.0346. So pornography explains about 3% of the variance in physical infidelity. We get our mean squared error, our F, our degrees of freedom, a P of 0.0039, so the model is significant. We then get our estimates of our B values, our constant, which is significant, and then the B value for pornography. And again, this would be the direct effect without controlling for the mediator, or what they're calling the total effect. So pornography, the B is 0.5846, standard error T. The P is 0.0039. So again, it would be significant at the 0.05, 0.01 level. And then we get our confidence intervals. Okay, so all that is showing you then the total effect, the C part of the model. So this is really, if you want to think about it, this is C. You know, this is the direct effect between porn and infidelity. That direct effect. We now have what I think is a pretty complex and scary looking table, but it's not that complex. You probably really only need things above here, the top third here. You probably only need the top third. But what this gives you relates back to numbers we've already generated. So you can really go back and you can trace back and see where these came from in earlier output, which I would encourage you to do. And you can try to calculate some of the others, because Field has told you how to calculate them. So we'll start with the total effect of x on y. The total effect of x on y is that simple effect, or the C path, from pornography consumption to infidelity. It's what was given in output 11.6. So the total effect is 0.5846. That's the B parameter for the total effect, or for pornography in that model. And then, this is the rest of the data that accompanies that. Then you have the direct effect of x on y. And what this direct effect is the effect once you take out the mediator. So the direct effect is C prime. The direct effect is the effect once you take out the mediator. And I'm trying to look over to see. And again, this is found in output 11.5. So if you look in output 11.5, you're going to find this direct effect. So the direct effect is the effect, it's the C prime effect, or the C prime path. It's that effect of x directly on y once you control for the mediator. And in this case, again, it was 0.4573. And then we have this accompanying information. You can see, again, it is significant as well. So both the total effect and the direct effect are significant. Then we have the indirect effect. The indirect effect is that effect that's left over in a sense, right? It's total effect minus direct effect. There's another way to calculate it, but for right now, we'll just say it's direct effect minus total effect. And so we can see that the indirect effect of x on y has a B parameter, associated B parameter of 0.1273. And you can see again the accompanying confidence intervals, the lower value and the upper value. So that's your indirect effect of x on y. And you can see that this does not include 0. Although I think some people would caution you against just looking to see if this includes 0 to determine if this indirect effect is in fact significant or not. So some people would caution against using this to determine whether the effect is significant or not. And then we went through some of these slides. They calculate or give you a number of other measures of the size of the effect: the partially standardized indirect effect, the completely standardized indirect effect, the ratio of indirect to total effect, the ratio of indirect to direct effect, and the R-squared mediation effect size. So you could see this as, in a sense, again, as trying to get at significance. Again, if it doesn't include 0, it would suggest that it is, in fact, significant. I give you a second to look at that before we move on. Okay, at this point then in the output field gives you the Sobel test. So this would be the Sobel test. It's the normal theory test for effect size. And you can see the effect size matches 0.1273. Now, in this case, though, it's actually not significant. It's 0.0509. All right, is that significant or not? This could be an interesting debate, right? Debate it among yourselves or in your own head. What's the cutoff for our alpha? It's actually equal to or less than 0.05. Is 0.0509 equal to or less than 0.05? Well, it's not less than, but if we round it off to 0.05, it's equal to. And so then we could argue it actually is significant. Anyway, however, it's not really significant because it's not equal to or less than. I guess it's more than. So Field in the book points out this is why he doesn't really like interpreting the Sobel test. He prefers to interpret the confidence intervals on the B estimates, or the parameter estimates. And so he prefers to interpret those confidence intervals, whether those confidence intervals include 0 or not. So again, there's two ways to look at significance. Do those bootstrapped confidence intervals include 0? Or what's our p-value? Field is suggesting he places more confidence in those bootstrapped confidence intervals. And if we go back to the bootstrap confidence intervals, then the indirect effect was in fact significant. All right, at this point, we now have all of our output. We're ready to interpret this. How should we report or interpret it? Field suggests saying there was a significantly indirect effect of pornography consumption on infidelity through relationship commitment, and then listing the associated b-value and the confidence intervals from our bootstrapping. So that's how Field suggests to report this. I mean, you might, of course, want to report more of the output. You might want to give each of the paths some more of the regression results, etc. But this is how Field suggests reporting the basic results from this mediation analysis. That in fact, we do have a significant indirect effect. Of course, we can note that we are left with also a significant direct effect. There is a significant direct effect as well as a significant indirect effect. So the total effect is not totally explained by the mediation. So the total effect in this case is not totally explained. The total effect is not completely explained by the mediation. Rather, both the indirect effect and the direct effect in this particular case are significant, if that makes sense, and hopefully it does. Okay, so going on with reporting the mediation analysis, I said you might also want to report each of the b-values. And in fact, here Field is doing that in by adding them to the model. So we can see the direct effect, the indirect effect, the A effect from pornography consumption to relationship commitment, and the B effect from relationship commitment to infidelity. I say B, there's double B's right there, right? It's the B value associated with the B effect or B path. So if we remember, if we go back, this was your A path, your B path, your C path. So this is your B for your A path, your B for your B path, and then your B for your C path in terms of, well, this would be your B for your C path, the direct effect. And then, of course, it's also telling us what the indirect effect is of pornography consumption through relationship commitment and through infidelity. One of the things you'll notice here, I'm repeating this slide for a reason. One of the things you'll notice here is that if you multiply the A path times the B path, so go ahead and multiply the A path times the B path. Multiply negative 0.47 times negative 0.27, it comes out to be 0.13, the indirect effect. Okay. All right, we're going to return to our COVID problem. Now, for this COVID problem, I decided to do something a little different to look at mediation. And I have trouble saying this word. An epidemiologist, is that correct? Don't judge me too harshly. An epidemiologist believes that the effect of density on deaths, so the population density on deaths, is mediated by air pollution. Okay, so we're going to add in air pollution. Now, I have a little note here that all the other data in this database are real except for air pollution. I made that up, but that's no longer true. This is the kind of service I deliver to you. I was unhappy with having made up any data. So I actually went out and got the air pollution data for each state. Now, what this air pollution data is, it's really a rating of how healthy the air is. And the lower the number, the healthier the air, the less air pollution. So a lower number is less air pollution, but it's a rating of how much air pollution there is. So we're going to do a COVID problem. We want to see if the effect of density on COVID deaths, population density on COVID deaths, is mediated by air pollution. I'm coming to you to interrupt this TV show to just make a correction. So just so you have it correct as we go through these slides, I want you to know or remember that despite what I say, death pop is deaths per million. It's not per thousands or hundred thousands. It's actually deaths per million. So again, the error, the problem came about because the world site uses deaths per million for each state. On the other hand, most other people use deaths per 100,000, and also for most of the other variables, they used 100,000s or things per 100,000s. So I actually changed in the database the variable or created a new variable that was deaths per 100,000. But then a lot of times I still went back and used the death per million variable by my error. So all it does is put anything off by a factor of 10, really. It doesn't affect the interpretation of any of the analyses, but it does put things off by a factor of 10, and I apologize for that. But instead of changing all the slides, I'm just letting you know that whenever it says death pop, that's deaths per million, not per thousands or hundred thousands. And I thank you for your understanding with this issue. Okay, so I ran the process model just like our friend Field did. I went into the menus and I chose model 4. So you can see I chose model 4. Again, it took me a while to figure out where to put that model 4, but I chose model 4. Again, if you don't pick the right model, you're going to get errors. And I said the Y variable or outcome variable was deaths due to COVID. The X variable was density or population density. And the mediator variable was this air pollution variable. And of course, our sample size then is 50. So then again, we get our first piece of outcome, which we're going to sort of parallel the field analysis. So our outcome variable is air pollution, which is the mediator. Our predictor is density. So this is really the A path. You can see that there's a high correlation between population density and air pollution, 0.4078. Here's our R squared, our mean squared error, F, degrees of freedom. Our p-value is 0.0033. When we look at our model, our coefficient or our B coefficient is 1.6549. And now, I asked for standardized coefficients just because I was interested in them. So I did add in that I wanted the standardized coefficient here. Again, though, this is our unstandardized coefficient, standard error, t-value, associated p-value, 0.0033. Of course, it matches what's up here. And also, if we look at the R square, population density explains about 17% of the variance in air pollution. Okay, then for the next analysis, we're going to be looking at deaths in the population as the outcome variable. And now we have in here two independent variables. Well, really an independent variable in the mediator. So the independent variable or the predictor variable is density. The mediator variable is air pollution. And we also have, of course, our constant in here. And so we can see that the, constant significant. Again, constant probably doesn't really matter all that much. We have our density data. And again, we can see that that is significant. So density is significant. And there's our associated unstandardized B or unstandardized B coefficient, the standard error, the t, the p-value, the confidence interval. And again, Field says interpret this confidence interval. If we look at the confidence interval, it doesn't include 0. Also, of course, air pollution, we want to see, does it predict deaths in the population? In fact, it does. And again, this is it. Both of these are after controlling for the other variable. So air pollution predicts deaths in the population after controlling for population density. The B coefficient, or the unstandardized coefficient, is 0.1432. You can see our standard error, our t, our p, it's significant. The p-value is 0.0078, which is below 0.05 and below 0.01. So we're okay there. So now we get to our direct effects and our indirect effects. I cut this off to make it fit, although we'll see what's on the next page. But I cut this off to make it fit. So you can see our direct effect. Our direct effect here is 0.6820. So again, our direct effect would be that part of the total effect that's due to the direct relationship between density and deaths after we control for air pollution. And then we have our indirect effect, which is 0.2370 for air pollution. And again, you can see this is significant when we look at the confidence intervals.